Okay, for the next little bit that we're going to do, we're going to have a look at some fractional indices, exercise 12.7. First, I just want to sort of show you how the connection between surds and indices is there, and then after that we can sort of look at more fractional indices. So going back to surds, chapters 12.1 to 5, we can see that root 3 multiplied by root 3, hopefully you realise that that is just 3. I mean, you could go through the long process of saying that it's root 3 times 3, which is the same as root 9, and then root 9 is the same as 3. But hopefully by now you've got to a point where you can say that root 3 multiplied by root 3 is just 3. Now the thing I guess I want to tell you is that that is 3 to the power of 1. Now if it's 3 to the power of 1, that means that this one here and this one here, they have to have the same powers, and when you add them together, because obviously we're multiplying the things together, when you add these powers together, it becomes a 1, and they have to be the same. So two things that are the same add together to get to 1. I mean, the answer becomes a little bit obvious now. Hopefully this one here needs to be 3 to the power of something, not 0, but 3, I'll put a square, 3 to the power of something times 3 to the power of something. Those two squares need to add together to get to 1. What do the squares have to be? 2 squares equals 1. The square must equal a half. So what we can say is that root 3 is actually 3 to the half. So 3 to the half by 3 to the half equals 3 to the power of 1. So this is kind of where surds and indices link up together. I'll kind of keep all that working there just so you can see it yourself. But that means that we can come down to some of our surds down the bottom here and transfer them into indices. So root A simply becomes A to the half. Okay, and you can transfer either way. So you can go from root A to the half, and you can also go the other way around as well. This one, the cubed root of A, again, I guess I could explain by doing this. The cubed root of the cubed root of 2 multiplied by the cubed root of 2 multiplied by the cubed root of 2 is, once you've got all three of them together, that should be just 2. That's 2 to the power of 1. So what do these have to be? That means that this, that would have to be 2 to the third by 3 and 2 is a bit weird, but 2 to the third and 2 to the third. Okay, because a third plus a third plus a third is 3/3, which is 1. So that means that this one here becomes A to the third. Okay, hopefully that's fairly self-explanatory. Now, if this number here was an invisible 2, and that's the 3, and those numbers are on the bottom, it means that this one becomes A to the 1 on n. So whatever number you've got there, that number goes on the bottom. If it's invisible, then we treat it as a 2, but otherwise that number goes down the bottom there. So that's how the fractional indices and surds sort of link up together. Let's have a look at this one now. This one's a little bit trickier. This one you can put in a variety of different ways. I'm going to say that it's A to the m, all raised to the power of 1 on n, which is what we had before. Now the only difference is that I've changed the A to an A to the power of m. Or I could actually write this as A to the power of m times 1 on n, and whenever you multiply fractions, you multiply the tops and the bottoms, so it's m over n. So that becomes A to the m over n. Or you could put it in a different way. It could actually be A to the 1 on n, all to the power of m. Because I guess you can change those two powers over. All of those can be incredibly useful. Let me just show you a quick example of why this one can sometimes be really powerful. If you feel not that confident at the moment, then just skip over this bit. But if you feel nice and you want to have a look at it, please do. Imagine I had, I've just got to think of one on the spot. Imagine I had, say, 16 to the power of 3 over 2. Okay, that's a little bit tricky to do this one, and it's probably not something I wanted to show you straight away, but let me show you why this one can actually be really good. first of all, I'm going to put it in the first format here. So that's 16 to the power of 3, all to the power of a half. Now that's hard to do because 16 to the power of 3, that's incredible. Like I can't even do 16 to the power of 2 in my head. So 16 to the power of 3 would actually be really, really tricky. I could do it and then get the square root of that, but getting the square root of a massive number is going to be really hard. So instead of putting it in that format, it wouldn't be wrong, but it's just hard. I want to put it in this format here and make it 16 to the power of a half, all cubed. Now we're sort of getting to what I'm going to go on to next. I'm sort of jumping the gun a little bit, but I can do this now because 16 to the power of a half, remember to the power of a half is just a square root. So the square root of 16 is actually just 4, and then 4 cubed, I can actually do that fairly simply. 4 cubed is actually 4 times 4, which is 16 times 4, which is 64. So all of a sudden, something that looks really nasty can look, not that bad. And it was much easier to do it this way than it was to do it this way. That way I would have had to been getting 64 squared and then getting the square root of 64, which I really have no idea how to do. Okay, we'll jump back into these ones. So if you want to, if you've tuned out for a little bit because that one was a little bit tricky, come back to this one over here. So 27 to the power of a third, the way that I like to go about these ones is that I like to put 27 in the smallest possible base that I can. Is 27 one of those numbers that, can I reduce that down to a small base? I hope I'm explaining myself well. That one I would turn into 3 to the power of 3. And there's really no quick or easy way to do it. It's just sort of practice and remembering, the cubed numbers and the squared numbers and that sort of thing. Hopefully we don't ask you too many nasty things. So that becomes 3 to the power of 3, all to the power of a third. And now, remembering that whenever we've got brackets, we just multiply. That one becomes 3 to the power of 3 times a third, which is 3 to the power of 1. Okay, so I'll do a similar sort of thing with this next one. 16, can I reduce that down to a smaller base? Yes, 16 and 2 I know are related in some way. So this one becomes 2 to the power of 4. Or you could have done 4 to the power of 2 as well, actually. Let's do that one first. That one might be a little bit easier for you guys to get. 16 can become 4 to the power of 2, all to the power of a quarter. And then that becomes 4 to the power of 2 times a quarter. So I'll skip that step a little bit. So that becomes 4 to the power of 2 over 4, which is the same as 4 to the power of a half. And remember, the half means the square root. So the square root of 4 is just 2. Now doing it the way that I was going to do it in the first place, it's going to be 2 to the power of 4 multiplied by, all to the power of a quarter. And then when you've got the brackets, you can multiply the power, so that becomes 2 to the power of 4 times a quarter, which is just 1, which is the same answer over there. Okay, last thing I want to do is just remind you of adding and subtracting fractions, because sometimes you're going to get something like this, the cubed root of a multiplied by the square root of a, which turns into the a to the third multiplied by a to the half, and then when we multiply the numbers, we add the fractions together. So how do we do a third plus a half? Okay, so when we're adding fractions together, go back to year 7, that's when you probably the last time you used fractions in any sort of serious way. This one becomes like a third plus a half. That a third plus a half becomes, I need a common denominator down the bottom, and the easiest way that I can do this, there's lots of different ways to do this, and sometimes there's more simple ways, but the way that I'm going to do it for right now is I'm actually going to multiply those two together, so the 3 and the 2. The reason I do that is because this one needs to be, like the denominator overall needs to be a multiple of both of those, and the quickest way to get a multiple of both of them is to multiply them together. So that becomes 6 and 6. Now I've got two fractions with a 6 on the bottom. What do I need to do to multiply the 3 to get to the 6? Well, I needed to multiply that by 2. So therefore I multiply the top by 2 as well, becomes 2 over 6, and I multiply the bottom by 3, so I need to multiply the top by 3. And when I add those two together, that becomes 5 over 6. Okay, so this answer down here, if we were going to go back to this one, that one would be a to the power of 5 over 6. Okay, so hopefully now you can do some of the exercises from exercise 12.7, and let me know if you have any questions. Thanks very much.